Hello, students. Let us systematically solve question 40 from the AP EAPCET 2026 mathematics paper. The question reads, in a binomial distribution, q plus p whole to the power of n, if q minus p equals 1 by 4, and the product of its mean and the variance is 45 by 8, then probability of x equals 2 is exactly what? Option 1. 126 into 5 to the power of 6 divided by 8 to the power of 8. Option 2, 252 into 5 to the power of 6 divided by 8 to the power of 8. Option 3, 63 into 3 to the power of 5 divided by 5 to the power of 6. Option 4, 72 into 3 to the power of 5 divided by 5 to the power of 6. To solve this complex problem quickly, we must first find three unknown values: the number of trials, n, the success probability, p, and the failure probability, q. Let us explicitly start with the first given equation. We are given q minus p equals 1 divided by 4. Now, every student must remember the hidden universal truth of binomial distributions. The sum of failure and success probabilities is always exactly 1. By placing these two linear equations neatly together, we can logically add them to use a simple elimination shortcut. When we add them directly, negative p and positive p cancel each other completely, perfectly giving us 2q equals 5 divided by 4. Dividing by 2 on both sides, we instantly find our first crucial variable, q equals exactly 5 divided by 8. Since q plus p must logically equal 1, simply subtracting 5/8 from 1 gives us our second variable, p equals 3 divided by 8. Now we confidently move to the second given condition. The question explicitly states that the product of the mean and the variance is exactly 45 divided by 8. Expanding this directly looks like an algebraic nightmare. Instead, let us intelligently write the standard formulas. The mean is defined as n times p, and the statistical variance is n times p times q. The core shortcut here is to mathematically multiply these abstract variables first. np multiplied by npq cleanly becomes n squared p squared q, so we confidently equate n squared p squared q to 45 divided by exactly 8. Now, we can carefully substitute our discovered fractional values for p and q directly into this clean equation. Substituting them, we get n squared multiplied by the square of 3/8, which mathematically expands to exactly 9 divided by 64, multiplied by 5/8 equals 45 divided by 8. Let us systematically simplify these fractions in real time. 9 into 5 perfectly makes 45, which cleanly cancels the entire numerator on the right side of the equation, and multiplying the remaining denominators mathematically isolates n squared, leaving us with a beautiful simplification where n squared equals exactly 64. Taking the positive square root, we successfully get our final unknown value, the number of trials, and equals 8. With all variables unlocked, n is 8, p is 3/8, and q is 5/8, we now confidently deploy the standard binomial formula to find the probability of x equals 2. Substituting our values, this probability is given by 8c2 multiplied by p squared multiplied by q to the power of 6. Expanding this carefully step by step, 8c2 mathematically resolves to exactly 28, p squared explicitly becomes 9 divided by 64, and q to the power of 6 remains 5 to the power of 6 over 8 to the power of 6. Finally, we seamlessly merge this arithmetic. 28 multiplied by 9 cleanly gives 252 in the numerator. The denominators combine systematically. 64 is 8 squared, which multiplies with 8 to the power of 6 to yield 8 to the power of 8. This final calculation perfectly matches option number 2, 252 into 5 to the power of 6 divided by 8 to the power of 8. And by beautifully combining linear equations with standard distribution rules, you bypass the entire algebraic nightmare.